Okay. You guys see okay? Let's move that over there. All right, so here are the reciprocal identities. So reciprocal and some of these should be familiar, but I'm gonna go ahead and put them all in one place. So sine of, they use u, but I'm gonna use x just because I like it. Sine x is equal to 1 over cosecant x, right? We're familiar with this. Cosine x is equal to 1 over secant x. Tangent x is equal to 1 over cotan x. Cosecant x is equal to 1 over sine x. Secant x is equal to 1 over cosine x. Cotan x is equal to 1 over tangent x. See, these are all the reciprocals that we're going to need. Quotient identities that we've mentioned before. It's the next ones. Oops, typo. Tangent x is equal to the quotient of sine x over cosine x. Cotan x is equal to cosine x over sine x, right? These are all, I'm assuming, very familiar. Pythagorean these all come from the original. Sine x squared plus cosine squared is equal to 1. So you can make 9 total formulas out of this guy. I guess 8 more, 9 including this one, right? And the 9 come from dividing both sides by different trig functions. So if I divide every single piece by sine, let's do cosine first. If I divide this by cosine, this by cosine, that by cosine, I'm going to get tangent squared x plus 1 equal to secant squared x. If I divide everything by sine, I would get 1 plus, let me see if I can write this a little more compact. So I need to have 3 sets. Yeah, let me see, just make it all small. It's okay. All right, we said divide this by cosine, we would get tangent squared x plus 1 equal to secant. Divided by sine, we'll get 1 plus cotangent squared x equal to cosecant. So once you have these, all you have to do is move them around and you'll find 2 more, which will give us a total of 9. 2 more for each set. Okay, so if I subtract sine squared, we get cosine squared x equal to 1 minus sine, right? If I subtract sine, I get, I'm sorry, if I subtract cosine, I get this one. Just doing basic algebra. If I subtract the tangent, I get 1 equal to secant squared x minus 10. If I subtract the 1, I get 10 squared x equal to secant squared x minus 1. Okay, now go to this one. If I subtract the cotangent, I get 1 equal to cosecant squared x minus 1. Subtract the cotangent. Oops, that's wrong. Let's subtract the cotangent. I get 1 equal to cosecant squared x minus cotangent squared x. Subtract the 1, I get cotangent squared x equal to cosecant squared x minus 1. So the 9 formulas, building them off of one original. You can put that in a note card if you like, doesn't matter, but you're gonna need them all. All right, cofunction. Identities. So sine of pi over 2 minus x is equal to cosine. So this is just a shift that will give us the other function. If I do the other way around, if I do pi over 2 minus x, then I get the sine. Oops, 2. Tangent of pi over 2 minus x is equal to cotan x. Cotan of pi over 2 minus x is equal to 10. So you can just do a simple shift to get the other function. Horizontal shift. Pi over 2 minus x give us cosecant. Cosecant minus pi over 2 minus x gives us secant x. Okay. Let's see what else. What other formulas we got? Oh, even and odd. I forgot about those. Even and odd properties. So sine of a negative x is equal to negative sine x. Cosine of negative x is equal to cosine. Okay. Cosecant of negative x is equal to negative cosecant of x. Secant of negative x is equal to secant of x. So this is an even one, right? These are the evens right here. The rest are technically odd. There's only 2 evens, and it's these 2. Okay. Tangent of negative x is equal to negative 10. And cotan of negative x is equal to negative cotangent x. All right. I think that might be all of them. Let me double check. Yeah, that's it. So we're gonna need all of these to start doing the homework. And I'll wait just a moment. So these are the definitions of even or odd. So the only trig functions that do this, have this property here, is the cosine and the secant. That makes sense, or does that help?
That does help. Thank you.
Okay. But yeah, the visual, like you said, the easiest one to think of is a parabola. So visually, this is an even function. It's a specific even function. And if you were to test to see if it's even there, it would have to follow that definition I wrote down. But a function doesn't have to be one or the other. It could be neither. It doesn't have to be even or odd. Okay, let's look at the homework problems. So 7-1 just kind of wants you to test. It starts out by testing you on the basic properties we just wrote down. They ask you, what is sine squared plus cosine squared? Well, formula says 1. This right here is testing you, do you know if it's odd or not? Odd function, right? If I plug in a negative sine, that's some negative angle, that's the same as doing negative times the sine of that angle. So visually, that's the same as saying this, really. So if we had a sine function, sine of 90 degrees, make it an easy one. No. Pi over 2. Negative sine pi over 2 biscuits. Okay. So notice that if I plug in the negative, sine of a negative pi over 2 is the same as a negative sine pi over 2. This is the definition of an odd function. So going in the negative direction on the circle is the same as going to the positive direction and then just swapping the sign. That's all odd means, that it fits this definition. Where is it? Oh, here it is. So let's say here they're just asking you what happens when you plug in a negative. Well, by the odd definition, this happens. And so the first few are just testing your knowledge and the definitions and formulas I just wrote down. So all you got to do is read them off of there. Good. We don't really start solving until here. So let's start number 9, where we actually do some work. The rest are just, can you quote the formulas? I do not expect you to memorize them because I don't like to memorize things. So I don't expect you to do that. Let's see, example 1. Problem 9. Okay. So tangent of theta times cotangent of theta over secant of theta. So it helps to understand or to have the formulas ready. So they want to know what is all of this going to simplify into. So the instructions say, basically in a nutshell, simplify. I'm not going to write the whole thing because that's all they're really asking. Number 9. So this all needs to cancel and become something simple. So let's use our quotient property, right? What is tangent as a quotient? What is cotangent as a quotient?
Sine over cosine and cosine over sine.
Right? So let's change it and see what happens. So that'll be sine theta over cosine theta for the tangent times, and then cotangent you said was cosine theta over sine, right? So that is the numerator after applying the quotient. What is secant as a reciprocal? Yeah, that's 1 over cosine. You're right. Now that I've applied this, multiply this. This is just a fraction, right? Two fractions times each other means, I mean, we don't have to show this step, but I will just this one time. But technically, these are all going to cancel, right? The reason they cancel is because when you multiply, this happens, right? So now all we have to deal with is this cosine. So that becomes a 1, because everything canceled out, over 1 over cosine. And when you divide by something like this, you end up with 1 over 1 times a reciprocal, right? Over 1, which is basically cosine. So all this nonsense simplifies to a cosine. And that's what they wanted to see. Any questions on this problem? So you see how we're using all the formulas I just wrote down, right? To simplify this little expression here. That's all we did. I rewrote tangent, cotangent, and did algebra. That's what this question was about. And the reason we're doing that is to kind of solidify our formulas by practicing these simplifications. I'll take another one if you guys are okay with this one in just a moment. Okay. So there's a couple of things we can do here. I would suggest, let's see, use fundamental theorems to simplify. Okay. So all we got to do is simplify. I noticed that they both have sine squared in common, right? So let's factor a sine squared. Now look at your formulas. What is secant squared minus 1? Is that one of the formulas? So from here to here, all I did was factor. Yeah, this is tangent squared based on the formulas I wrote down. The Pythagorean, part of the Pythagorean formulas. So from here to here, I use the Pythagorean identity or whatever you want to call it, formula. Any questions on number 11? That's as simplified as we can make it. Okay. Let's do, no, this one looks kind of hard. problem 12 in your homework. Still simplify. 1 minus 2 cosine plus cosine to the 4th x. Okay. Let's see here. Well, a couple things we can do. It looks like it could be a quadratic form. So you could attempt that, or you could try rewriting it as squares and then replace everything with sine squared and see if stuff cancels. Let's see.
Sorry, sir, I can't really read your handwriting. Is that a 4
Where at?
above the cosine x?
Yeah, it should have been a 4. I just smeared it.
Sorry about that.
It's okay. Anytime, let me know if you can't read something. I know how I write. It's not the best. So it's 1 minus 2 cosine squared plus cosine to the 4th. All the arguments are x. Okay. So what do you guys think we should do first? Based on the formula, we know that cosine squared, let's try this route. I don't know if it's the best yet, but I'm just gonna try something. I know cosine squared is good at this, so I could rewrite this question like this, right? Using our knowledge of algebra. Do you agree that this is the same? Cosine squared squared is the same as to the 4th. And I can just isolate this cosine squared here. And I can replace each one with 1 minus sine squared. And hope that helps me with something. Let's see. Okay. If I distribute this and this guy, I'll get 1 minus 2 plus 2 sine squared x plus distribute this out, multiply everything out, you'll get 1 minus 2 sine squared x plus sine to the 4th x. It's doing FOIL or multiplication, whatever you want to call it. You're going to get this, right? You guys cool with this algebra so far? All right, distribute the 2 on both of these. Multiply this twice. Then you get these 3 terms.
So the 2 sine squared x will cancel out, right?
Yeah, these are going to be gone. So 2 sine minus 2 sine, those are gone. 1 plus 1 minus 2 is 0. So I'm left with only this. Everything else cancels. So using that identity, we got to simplify the question. So right here, all you have to do is replace this guy and this guy with sine squared, 1 minus sine squared. And there's not just one way to do this. That's just the way that I chose. I did write kind of small, so let me, you guys see that okay? Any questions on problem example 3? All we're doing is playing with identities and simplifying the problem with algebra. We are not solving for anything. Okay, let me look at our schedule real quick. I forget where we're at. Oh, that's right. Cool.
Wait a second, sir.
What's up?
I'm sorry, I had to like actually write it all down before I could think of a question. Can you show us where it canceled between the 1 minus 2 plus the 2 sign and
Sure.
the 1 minus 2 times the 2 sign? Because it's the difference between the multiplying and the addition. That's,
So you're cool with how it all came out, right?
yeah, I'm good up to that point.
Okay,
And then,
so,
then you lose me.
all right, let's do it. So you see there's a 1 and a 1, right? So that's 1 plus 1. You agree?
Yeah,
And there's a minus 2 right there, correct? This one.
yeah.
And then there's a plus 2 sine squared x minus a 2 sine squared right here, correct?
Yeah.
So all those, do you agree, will cancel, except this last term?
Oh, okay. No, I get it. It was just the multiplication. It looked like do you see what I saw? Do you see what I saw?
Did it look like these were like one units or something, or 1 terms?
Yeah. Yeah.
I can see where you got lost, yes.
Okay. Thank you.
I get it. But just remember that what a term is, right? The term is just something separated by a plus or a minus. So you can move these around any way you want, as long as it's not a product. So I put these together, this 2 together, these together. And now it's super obvious, right? These are all gone. So you can do that anytime you like.
Thank you, sir.
Let's do another one. So pretty much all of this, the entire homework is just doing this over and over again. Just they give you some weird thing, you apply one of the formulas and see what cancels, because that's all you're going to be doing for all of these problems. Let me delete some so it's not too long. This one seems stupid. This one is repetitive. Okay. I don't think that's necessary. There we go. I deleted a little bit, shorten your homework as much as I could. All right, number 13. So example 4. Problem 13. So simplify again. This entire chapter section is simplify. The next section, which we'll do on Tuesday, is going to be proving theorems or proving statements or proving something is true. So all this will be very useful to have down before Tuesday. Because that section can be difficult for some people. Excuse me. All right, so simplify this nonsense. What is the what is the even or odd property for tangent? What happens when there's a negative angle in there?
It becomes a positive.
And where does the negative go? Does it disappear or does it go somewhere?
If I wrote it down right, it just disappears.
Let's see. Tangent ends up in the front. Minus.
See, yeah, I wrote it down wrong.
So the only ones that disappear are the even functions. So only the cosine and secant will they just vanish. The rest will have a minus in front. So only even functions absorb negative angles like that. So this guy will have a negative come outside. That is a property of odd. That's what it means to be odd, at least analytically. Graphically, it's different, as I showed you that earlier. So by definition, that's what happens. So now, what property would you use to simplify this further? Right now, I use even odd property to begin with. Yeah, quotient. So whenever you see a tangent, most of the time, changing it into a quotient is a good idea. So that would be -2 sine over cosine, right? So that was the quotient property that I used. Now at this point, do you see what cancels?
Cosine.
Yeah, the cosines are going to cancel, aren't they? So from here to there, we just did basic algebra. Algebra. And that is as simple as it's going to get. And that's the answer. Let me show you the question. They give you this statement, and they want you to simplify as much as you can using all the properties I wrote down at the very beginning. This is as simple as it gets. And on an exam, I want to see as much steps as you can show. Like step 1, I use the even and odd property, right? Step 2, quotient. And then cancellation, algebra. Any questions on what we did here? I don't expect you to memorize every single property, but I expect you to be able to use them and understand them. I feel like that's reasonable. My professor made me memorize them. I thought that was very uncool. The first 15 minutes was me writing down formulas because I don't want to forget them. I hated it. Crazy old man. He would throw chalk at us if we weren't paying attention. He was one of those old school professors, and I don't know what, if you know what I'm talking about. Anyway.
Oh, my algebra 2 teacher was like that.
Yeah.
Yeah.
It's very old fashioned, guys.
She was proud of herself in the fact that she was the bionic teacher.
So
No
you sound
joking, I
like
graduated from Seguin.
she sound like a character. Where'd you graduate from?
Seguin.
Oh, gotcha.
My high school had a daycare, okay?
Oh, nice. I feel like that should be more common. But that's my own opinion.
I thought it was a natural thing, like a normal thing, until people started telling me otherwise, and I was like, "Oh, okay, skiing is ghetto apparently."
Well, I mean, I wouldn't say it's ghetto. I just think, I mean, most schools in the ghetto, I don't think have that option. You would think they would put that in like the east side or west side, but I don't think that's a thing. I think it's pretty cool. It's helpful. Let's see here. At least back in my day, there wasn't. I don't know. I could be wrong about nowadays. Alrighty. So the next one, let's do this quotient. This fraction looks annoying. I want to try to do the hard ones with you. Before I let you go, let's do the ones that might be confusing. Okay. So this guy, I'm going to change the variables to x. It doesn't matter, it's just preference. So that's what we start with. They want us to simplify as much as possible. There is no one way to do this. And you'll get better and better the more you practice, and you'll start to see like some common ideas and whatnot. But since you see a square, what do you think we should do? That should be the only hint you really need once you have these identities down or you're comfortable with them.
So that whole thing, the cosine squared x, it's the cosine squared x equals 1 minus sine squared x.
Yeah, the top part, right?
Yeah.
Yeah, this is a Pythagorean identity, so you're right. 1 minus sine squared is what cosine is. So right from here to here, that's Pythagorean. Identity, whatever. Right? From your formulas. Now at this point, we can do algebra. What is 1 minus sine squared? How do we factor this? Do you remember? Is it familiar? Yeah, this is going to be a difference of squares. Do you guys remember the difference of squares? I'm going to write the formula if you don't. Factor using the difference of squares. A squared minus b squared is equal to a plus b times a minus b, right? Is that familiar? So we had a squared minus a b squared. That was our difference of squares. So this factored into a minus b times a plus b. That is this formula here. At that point, these cancel because they're products, leaving us with 1 plus sine. That is as simplified as it's going to get.
Oh.
Any questions on any of these steps here? That's how they get this. They don't really say anything. You're just supposed to do that on your own. So I'm trying to show as many steps as I can to help you out. Any questions on this? Yep, just gonna assume you guys are pros. I got it. You guys have any other questions on previous sections? You guys doing okay on chapter 6? Because this is the beginning of chapter 7. It's cool on the word problems or the triangle problems.
So I had a problem with 8 and 13 from homework on Tuesday, like,
Okay,
because 8 gave the 3 sides, I think,
let's see.
and then 13 you had to just confuse the crap out of me.
Okay, let's look at number 8 first. So everyone's cool with me moving on, right? Moving on to, or at least back to chapter 6. So you had something like this, you had 2 sides.
Yes,
Okay,
no angles except for the right angle.
so you had the right angle and 2 sides. All right then. You could find the third side using Pythagorean, right? No big deal. But the other angles, let's see. Yeah, you want me to use your numbers? Doesn't matter to me. Or are these fine?
That would probably be easier and I wouldn't get confused.
Okay, yours or
Yeah, mine.
what is yours? Section.
Okay, so my little b was 17.6.
This was 6.7, right?
I think. Yes,
Your little b was, what was it again?
17.6.
And then little c.
And my little c was 53.18.
Okay. Hold on a second. It's gonna bug me. I don't know. A, B is 17.6. C is 53.18. Trying to be alphabetical. Not that it matters. We don't know capital A. We do not know capital B. We do have the right angle of 90. Right? So I know that a squared plus b squared is equal to c squared. I don't have a. So if I solve for a squared would be equal to c squared minus b squared, which means that a is equal to the square root of c squared minus b squared. So
50.18.
you got 15.18?
50.18.
Did they say what to round to?
Two decimal places.
All right, I'm just gonna double check because I don't want to, I'm paranoid. 3.18. Squared.
Can you make your other screen bigger?
Oh, yeah, right. Thank you. Okay. 17.6 is the other one. So yeah, 50.18, right? That's what you said.
Yep.
So we got all the sides. Now, I could use, let's say, sine of A. That would be equal to opposite over hypotenuse, right? You agree with that?
Yes, sir.
So sine A would be equal to 50.18 over C 53.18, correct? So,
And that's kind of where I stopped because I was getting really lost.
so if we use the inverse functions, remember how we can cancel the functions? So sine inverse of both sides would cancel the sine for you. So A is equal to sine inverse of this weird number. So that is approximately something. Second sine inverse of some fraction. 50.18. 53.18 degrees, right? Yeah. So 70.66 degrees is A. And once you have one, you can find the other. Once you have two, you can find the last one, right? So 180 minus 70.66 minus 90. So the last angle was 19.34 degrees. Any questions on that?
Nope.
So whenever you want to
Not now,
solve
anyway.
whenever you want to solve for an angle, introduce the inverse sine functions on both sides, because I needed A, and the only way to get A out is to cancel the sign. So go back to the inverse properties. And once you get that, just subtract the other two angles from 180 and you'll have the last angle.
Okay, I get it. I sort of get it now. I guess I have to keep working on it. Well, what about 13? That was that weird.
Oh, that's a word problem. Let's see.
Yeah, which
So here, excuse me. Find the length L and the measure of angles A and B. It appears that they're talking about these angles, A and B, outside the triangle. Okay. You agree that from here all the way to here is 180, right?
yes, sir.
And from here to there is 90. So let's see, what could we do to find the missing angles? Enforcement zone. Find the L won't be a big deal. Find the A and B will be strange. Let's see. One moment. Dang it, where'd it go? I think I closed it. Okay, there it is. Oh, forgot to hit record. Okay, so alternate angle. Let's call this angle A and A prime. So these are technically equal because they are alternate angles. So in our problem, we got this triangle here. And we got this car down here. So this is a right angle. We want to know these two right here. They call A and B. Okay, so A will be equal to this one here. So we'll call that A as well. And this one will be equal to B. So using this idea of alternate angles. Okay. The drawing's crappy, but who cares, right? So this length is 150. This length is 200. So we know that this side hypotenuse is going to be the square root of 200 squared plus 150 squared.
So 250.
Yes, that's right. Thank you. Okay. So we can do tangent of A, that would be equal to the opposite over adjacent, right? So take tan inverse of both sides to solve for A. So A is equal to this right here. So what is tan inverse of 200 over 150? Looks like 53.13 degrees. So that's this angle here, which means that's the same for this one. Okay. So going back to the question.
Am I supposed to have my I'm supposed to have my calculator in degrees, right?
Yeah. Yeah, for this question, yes.
See, can you see that?
Almost.
I don't know what in the hell just happened.
It doesn't look like anything we typed right now. It looks weird. Can you clear that and type it again? I don't know what happened there.
Yeah, I don't know how to clear it. My calculator's smarter than I am.
Oh man, it's scary.
But
Scary
that's what I
calculator.
typed in.
Uh-huh. Okay, see, that looks okay.
That's what it gave me.
What the hell? Man, I have yet to learn that calculator. I don't know. I hear great things about it, but it's pretty complex though. Ah, man. Okay, let's see. So
Okay, it's smarter than me.
did it come out or no?
Nope.
Dang it. Oh, sorry. I got these backwards,
It did the other one.
but not that one. Huh.
Nope.
Miss any parentheses or anything?
No. Tan -1, 200 over 150. I mean, all the parentheses are there, and it added a couple more that I didn't add.
It's fancy. Man, I'm sorry. I don't know what the hell's going on there. There we go. So I was trying to make sure I match up with this. So this B would be that B, this A would be that A. And to make sure.
You have to
it's-
convert to decimals.
I'm sorry.
You have to convert it to decimals.
Oh, is that what it was?
Yeah.
Oh, so that was like some weird exact answer. That's strange. Interesting. Okay, well. So A is equal to 180 minus 90 minus 53.13. What is that going to be? I got 36.87. Yeah, that looks okay. So we got B and we got A. So solving for those got me the missing pieces. So the length L is no big deal. That's just A squared plus B squared. That's why we get 250. So finding A, you have to do the inverse tan of the missing angle to solve for that angle. So opposite. Adjacent. Over adjacent. So yeah, they should give you the two angles here. But I think I might have labeled mine wrong. It's bugging me. But did you see the idea of these alternate angles?
Yeah. Yeah, I got that idea.
Yeah, that's all we're doing. You find the angles inside, and those are going to be equal to the ones outside. That's all you got to do. But I mislabeled mine. I'm sorry about that. Trying to see if I can make it simpler.
And then every time I tried to do because my miles per hour is 45. Every time I tried doing it, I was getting some weird, I'm getting 5.55 because it's distance divided by speed. So it'd be 250 divided by 45, right?
Let's see. So this is find the minimum amount of time in seconds it takes the vehicle to pass through the zone without exceeding the posted speed limit. So we had a distance of 250, right? Let's see here. Excuse me. So they want it in seconds, right? So we have to convert to seconds. I think that's the confusing part. Let me see. $25 miles per hour. You have 250 feet. Okay. So the enforcement zone, we'll call it E, is 250 feet, correct? Those are fine. So basically, how long does it take to hit 25 miles an hour in that zone? The 25 miles per hour would be right. How many miles? How many feet are in a mile?
Something like 5,000.
Yeah, some 5,000
like that.
something. 1,280. There it is. 5,000. So I'd have to convert this to feet first. Let's see if this works. Well, hold on. Let me see if there's a shorter way. If not, we're gonna have to do a bunch of conversions. Yeah, I don't think so. Let's just go ahead and convert it to feet per second. So we said 5,280, right? I think that's what I said. 5,000. 5,280 feet per 1 mile. So I'm going to multiply this out. So that cancels the miles. So then we get 25 times 5,280 feet over 1 hour times, now change hours to seconds. We know that there's 3,600 seconds per 1 hour. So that would be 1 hour for every 3,600 seconds. That'll cancel. So leave me with 25 times 5,280 feet over 3,600. So what is that answer? Now it's calculator time. 25 times 5,280 divided by 3,600. Yeah, that's right. 36, not 36,000. That gives me 36.68 feet per second. Okay. So that's a conversion of 25 miles per hour to feet per second. Now they ask us, how many seconds would it take? Find the amount of time it takes for the vehicle to pass through the zone without exceeding 25 miles per hour. Okay, so if I have a distance of 250, 50, was it, what was the distance? 250, right? Or 200?
250.
So what would be the time? $25, 5280. Make sure I wrote down everything. Oops, I messed that up. That's 5280 there. Divided by 3600. Yeah, it should be 6.7. You're right, Joseph. Okay. So we got the conversion we need. Just to make sure we understand this question. Find the minimum amount of time it takes a vehicle to pass through the zone without exceeding. Oh, okay, true. I'm overthinking this. So if we convert the speed, right, to 36, if you're going at a rate of 36.67 feet per second, how long would it take you to hit 250? You just divide into 250. So the final answer would be 250 divided by this. So 250 divided by 36.67 is 6.82 seconds. That's all you have to do. So sorry, I wrote that wrong. No, that's fine. That's fine. 250 feet, 267 feet per second. Leaves me with seconds. Yeah, that wasn't a weird question. I did not mean to give you something that difficult. I thought it was going to be easy when I first saw it, but they threw in a couple of curveballs on B. They wanted you to do conversions before you could answer the question, which makes it a little more tedious. But once you change 25 miles per hour to feet per second, then you can use the feet of 250 to answer this question. But not until then.
Yeah, I got as far down as changing it into minutes. I didn't think about going down into seconds.
Yeah, that's all you needed to do is change the seconds and then divide into 250. I'm not going to give you anything like that on an exam, by the way. That's just a homework question.
Was that it for tonight, sir?
Yeah, that's all. You guys have any questions on anything?
No, I think I'm good right now.
Alrighty, so when we get back on Tuesday, we'll be doing, I guess, some proofs using the properties hour. So make sure you get those properties down before I see you on Tuesday. That'll make it easier.
Have a good night, sir.
Have a good night.
Thank you. Have a good night.
You too.